All right, great to see everyone. My name is Jonathan Turner. I'm the program manager at Microsoft on the TypeScript team. And this talk is TypeScript and Angular 2. You may have seen something similar to this talk at EdgyConf. This is going to be kind of a zoomed in, a little bit more detailed version of that. So we see TypeScript in a little bit more detail and how it works with Angular. So let's look at TypeScript. Because everyone needs concentric circles in their talk, I've got to throw in some concentric circles of my own. So TypeScript really starts and ends with JavaScript. And from there, it kind of builds out. So we have ES6, which really makes JavaScript a new language. And as I'm sure many of you have played with it, you really see that starting to come true for your own selves as the patterns that you're writing in ES6 kind of show a new way of doing JavaScript. With ES7, that's already being developed. We have kind of the future features of JavaScript. And finally, kind of the types in the TypeScript type system kind of tie together all of these features so that we have good tooling, good error detection through all those features. So let's zoom in a little bit into each of those. First off, ES5, JavaScript of today, right? Oh, no, not really, not anymore. TypeScript of yesterday. So thanks to the good work of the TC39 committee, we're now working on ES6 as the standard JavaScript language. But ES5 is still a vibrant, well-supported, of course, across all browsers, across all platforms. So being able to work with ES5 is still very important. In TypeScript, being able to work with ES5 starts because TypeScript is a superset of JavaScript. So those features that you're already using in JavaScript, the optimization patterns, the kinds of code that you're already writing, you can just copy and paste into your TypeScript project and get going from there. The TypeScript compiler takes that JavaScript and then will output clean JavaScript output. So if you kind of copy JavaScript in, you get JavaScript out. ES6, of course, then, is the JavaScript today. And it has a ton of new functionality, a ton of new features that really start to change how we do our JavaScript, change how we think about our JavaScript. Kind of just those first few lines alone, being able to work with classes, work with modules in a way that's a standard way of working with modules, arrow functions, just structuring, and so forth, give us a nice way of working with our code. Of course, TypeScript is kind of evolving along with JavaScript, so that with all these features in ES6, we're supporting them in TypeScript, so you can use them in a well-typed way that has good tooling. And just kind of as an example, I'm sure many have seen the kind of ES6 classes, but it really starts to codify the patterns that we had in ES5 in a way that's more declarative and more descriptive. And here's an example of modules. Instead of having kind of the ad hoc syntax of using require or common.js, we now have one standard module syntax that we can use. And it's powerful enough to be able to reach in and handle specific imports or to handle the imports as a group. With ES7, we're looking at new features that are currently being developed. So in TypeScript, there's two features that we're currently working on developing for the next version of JavaScript. One is decorators. Of course, we saw some of that yesterday with the examples there, being able to annotate the class or annotate methods, and then inform things like a dependency injection machinery or to add metadata. And of course, async await. So these, in the TypeScript compiler, again, we're using the full type system and type checking these so you can use them correctly. But these also are compiling down, so you don't have to wait for browsers to support ES7 or ES6. We can compile down and to ES5. OK, so let's talk about types for a little while. There's a lot of nice benefits of type checking. You can do nice error detection. So you can catch you from doing a whole class of errors that otherwise may be difficult to find, or if you haven't written the right set of unit tests to catch it, this helps catch it. It helps with refactoring. So for example, I can find all the places in my code that I can rename or kind of refactor out into a separate function. And then this will help catch all of the places because it knows the types through my system. And finally, code navigation, being able to actually navigate to all the places that this symbol is defined and used. But I think when people think about types, there's kind of a horror story that a lot of people think about, especially if we come from dynamic languages. If you're like me, and you kind of grew up when Java was what everyone learned, we think of types as this gross thing. Why do I have to write the same type multiple times? I should never have to do this. The compiler should be smart enough. Repeat after me. I will not repeat myself. I will not repeat myself. Right? I should never have to do that. I think another horror story that people have is they've played with type systems, and they're just like tearing their hair out, trying to understand them, trying to satisfy the type system so that it doesn't have errors, and that might take hours before it actually compiles. Please don't turn JavaScript into Haskell. Let's not do that either. So luckily, we're in 2015, and because we're in 2015, we can work with a modern type system that works in a nice way. So what would I define as a modern type system? Well, first off, it has to have good type inference. Like, don't make me write the types that you should be able to figure out yourself. Gradual typing. Don't make me write types if I don't want to write types. If I don't feel like putting type information in this area of the code because I'm still working on it, then don't make me put the type information there. And again, kind of make it configurable, so I can kind of set the dials to as high or as low as I want for what's appropriate for me. So let's actually take a look at an example. So I have this example. Can anyone see this okay? Should I zoom in? No? OK. Up. Better? OK. So in this example, I have, I've got an array of objects at the top, and I'm going to sort that array. I'm going to sort it with a little sort function, and then I can kind of print this out. Notice in this code, there are no type annotations anywhere. I mean, this is just JavaScript. But I can start asking the TypeScript compiler, what are the types of various things? So if I hover over, for example, enter HTML, it says, oh, I know that's a string. If I hover over A, you may be able to see the type floating there. It says, oh, OK, you're an array of an object literal that is a name as the property, and then the type of that property is string. And it's able to figure that out from that expression on the right-hand side. I mean, we can do that as people, but it's nice that the compiler is doing that for us, so we don't have to actually sit there and annotate it, where it should be able to just calculate out the type and tell us. So I can hover A, I can hover sorted. Again, it's got the type of that because it knows the type of slice, and so on. And I guess one of the even more fun ones is here. So we've got the type of sorted, which it's already calculated. From that, it can figure out the type of sort, which is a little bit more complicated because it's taking in a function and working over that function. And so we're passing a function. If I hover over X, it's been able to flow the type all the way through with each step into this function that's a callback, and then look at the two arguments of that function and say, all right, I know the two arguments of this function because I know I've been able to calculate the type all the way down. So this actually is a fully typed snippet of code, even though there are no type annotations anywhere. This kind of type inference is a really powerful way of getting started and working with TypeScript, because a lot of it is just kind of calculated for you kind of on day one when you switch over to the TypeScript application. Now, it's not going to be able to calculate everything. So of course, full disclosure, I mean, this isn't magic. So you will have to kind of annotate your code in places. But being able to have it kind of pre-calculate saves a lot of time. And just to kind of drive that home, the type inference can go right to left and can also kind of go left to right and dive in to expressions. So let's talk about gradual typing. So gradual typing is this idea that types themselves are optional. I can put in types where I want to have type information, or I can also turn type checking off by using what's called the any type. Here I have this variable x. I said this is of the any type. Anything that's of the any type, again, is kind of not checked by the compiler. I can, if I want to, assign a number into x, and I could also, right after that, assign a string into x. There's no checking there. I can also go from that x back to assign into, for example, here y, which is of type string. So I can assign anything into any, and from any into anything else. Now you may look at this and say, whoa, wait a second. Why are you letting me assign? I see what, the transitive closure here. I've just assigned from number to string. That doesn't sound very safe. And I would agree. That isn't very safe. But it's up to you as the writer of this code that you know what you're doing. And you're the one that says, all right, here's where I want the compiler to get out of the way so I can do something that's more dynamic, a little bit more special than I want the compiler to check. So here you can kind of set that dial based on kind of what's going on in your code. So all of these features work together to really make TypeScript pop as a language. And we'll see that here shortly. I'll give a demonstration of these working together. But before I do that, let's talk just briefly about Angular. So from TypeScript's perspective, Angular 2 has, there's a lot of principles behind Angular 2, but I pulled out what I would consider the 4 main principles when we think about how Angular 2 and TypeScript work together. The first one is that it's future ready. Really, a lot of the work that's been going in TypeScript is around ES6, ES6 patterns, ES6 features, and typing those well. And because Angular 2 is built up from the ground to be an ES6-rich environment, you can start to use those today. And again, of course, with decorators, you can even start to use some of those ES7 features. It's flexible development. So TypeScript, just because you're using TypeScript doesn't mean you have to use classes, doesn't mean you have to use decorators. You can just use ES5 and use like a typed ES5 if you want. So there's no requirement that you buy in to all features all at once. You make the choices that make sense for your application, and TypeScript can still be there kind of helping you along with the set of features that you opt into. Of course, it's simple and expressive. The templating system, the more declarative syntax, works better with tools like TypeScript, and you'll see some of that here in a minute. And finally, the dependency injection system that Angular 2 works with all works with decorators, and you'll see how all the decorators work with the type system. So with that, let's actually start giving a demo. So in this demo, let me pull up our code and get a quick check on the font size. Are we good? Font size? Bigger. Good? Okay, good. I'm going to have to do that a few times, so I'm going to look for that a few times. So here I've got Visual Studio Code, and I've got a small application that, let's do this guy bigger too, shall we? All right. And this guy, oops. Is that big enough? Just to check there, okay. So I've got an application here, and let me go ahead and run this. Let's do this in Chrome just for fun. Localhost 8080. All right, so this is our application. So in this application, we have a list of WAV files, and I can click that list of WAV files, and then it will draw on the left-hand side kind of what that wave looks like. If any of you did, your music in college and whatnot, this is going to look really familiar. So this is our application. And currently, this application is written completely in JavaScript. So let's take a quick look at this app, because we're going to be using this to walk through the various stages of converting it from an HTML, HTML5 JavaScript style application through TypeScript and then into Angular 2. We've got 3 main files: app.js, which is kind of handling how we do the updates, and it kind of loads our initial file for us. We've got audio file, and this is what's going to kind of parse in the WAV file format and create that graph. And then display audio, which is actually going to print that into the canvas for us. And real quick, so on the HTML file, we've got those 3 that we're loading at the top in our canvas and our select element. OK, so really, really basic, but just enough there going on that we can use this to kind of kick off our demo. All right, so the first thing that we need to do when we're converting to TypeScript is just as simple as it sounds. It's just move from app.js to app.ts. So we're going to do that for all the files. And now that all the files have been moved over, I can run all of these through the TypeScript compiler. Now we're going to get some errors coming out. It's warning us that there are things that it hasn't been able to figure out, but that's OK. If we look at the list of files, you'll notice that there's still been a JavaScript file created for each of those TypeScript files. And if we run the application, let me just reload, and then run the server. That would help. All right, so now, even though there are errors during compilation, the TypeScript compiler is still outputting valid JavaScript. So this kind of goes back to what I said at the beginning. If you put in valid JavaScript, you get valid JavaScript out. This happens even if there are errors. So the first step to working with TypeScript, you can kind of think of it as a dial. You can set the dial even at something close to 0 and not change anything in your files, and you still get valid JavaScript. For the compiler to start helping us, we actually need to start making changes to our TypeScript files. Let's see if we can do that. We can go in and start changing our files so that we can get rid of these errors. So there's a couple things I'll do next. The next thing I'll do is I'll create a file called tsconfig.json. Yesterday, you probably saw the / references. We are now working on this thing called tsconfig, which allows you to not have to do that anymore and just have a single file that represents all the settings for your project. So as long as this file is sitting in that directory, it treats the whole directory as your project. But here's one of the gotchas. So I'm using VS Code, which is a lovely editor, but it won't pick up changes in tsconfig because tsconfig is so new without a restart. So I'm going to end up restarting it a few times as we make changes to this file. So this will be the first time I do it. And then zoom back in. And now that I've made some changes, some of the errors have started to go away. So it's now able to know load file, which is in a different file. So if I click and navigate to that, notice that I can easily navigate to all the definitions that it's been able to resolve, which is very handy. The other thing that's going on is you can probably see in the back, there are some errors. It's not sure that I have an options property on file list. And that's because I'm reaching in to my HTML. I'm getting an element by ID, but this is something that's very specific to my web page. This is not something that the compiler knows about. So I need to give it a little bit of help. So there are a lot of type information that's available to you as a TypeScript user by default. So here, I happen to know ahead of time that this is an HTML select element. But by default, this thing understands this to be, you can see the return after the colon. It says HTML element. So it's like, I don't know which one it is. It's just some kind of HTML element. And how does it know that? Let's just go ahead and take a quick look at this file. Now, I don't want you to have to parse this whole file visually in your head. But just know that behind the scenes, that TypeScript is actually using this file to use for type inference, for understanding your code. This is called lib.d.ts. Lib.d.ts is the standard library of type information. It has the JavaScript API, and it has the HTML DOM. The whole DOM is there documented so that you can get all the type information. So let's go back to app.ts. So now that we've made that fix, we've now said, all right, this is something that's a little bit more specific. It has the features for options and whatnot, so this file can now type check. This file looks OK. That's good. And this one has a few issues as well. I notice it's the same kind of pattern. Get element by ID. We've got a wave view. We know that we need to probably cast this guy as well, so we'll go ahead and do that. All right, so we're almost there. There's one little guy here. Well, that's interesting. So type checker has found that I've misspelled something accidentally on a code path that may not have been unit tested as well. Perhaps all my WAV files are these, it's called 16-bit WAV file, but maybe I didn't have as many 8-bit WAV files laying around, so I just didn't catch this one. But the type checker is there catching us. And if we kind of click around, if we actually click on, see, something's not working. I click here, and if I pull up tools, developer tools, it's like, oh, there's errors here. This isn't working. So now, what we can do with the type checker, of course, is catch these kinds of things where the unit test wouldn't have caught them before. And then let's run HTTP server. And now for any of the WAV files, including this guy, which was an 8-bit WAV file, that now works correctly. All right, so we've now stepped through all the errors that are in our project. And again, you can kind of think of that as that dial. We haven't really cranked the dial very high. We've just cranked it just enough to get the type information in there to help us find some of those early bugs. The next thing that we're going to do is we're going to start refactoring our code to really take advantage of more of the features that are in TypeScript. The first set of features that we want to take advantage of are being able to use classes. So let's do that. In order to do that, I'm going to show off a couple other features here. So we have enumerations. So we can do that instead of the previous one. And it's very similar, except we can map back and forth between the name and the number. Next, let's go ahead and replace this constructor function. Notice this constructor function isn't really telling us much about what the class's shape is going to be. So we can take a more ES6 specific approach that has some TypeScript types in there too. And we saw this a little bit earlier yesterday, where you could have the actual properties and then the types of those properties. And once we've pasted that in, and we kind of hover over these, notice the compiler is, OK, now that these are instantiating, I can see the types. The next thing we can do, having this class here, because it doubles as both a constructor and as a type, we can start annotating where this type is going to get used. So let's go over to this file. And we'll say this one takes in one of these WAV files. Notice IntelliSense is kind of jumping in, helping me out, saying, oh, OK, I know there's a WAV file. We'll let you autocomplete that. And let me pull up these two side by side. So the next thing I'm going to do is I'm going to, let's say I want to refactor the properties in my WAV file. So I can rename, let's see, rename symbol, and we'll call this wave data. Now notice I've changed data, but these datas haven't changed. But where I've actually used it, for example, over here, we see wave data here and wave data here. So it was able to find every place that wave data, that symbol data was referenced in that particular way without renaming, of course, all the other symbols, which is generally something that static typing languages can do, but it's more difficult to do that properly in JavaScript. So this is kind of showing, we saw the net navigation, error detection, here some refactoring. And of course, we can build this and run it and show that we're still going. But let's actually take a little bit of a deeper look at what we can do with the type system. So the next set of refactoring that I'm going to do is I'm going to move from working in a wave file, so we've got a single class. Let's actually build up a bit of a class hierarchy. For example, I may want to work with more than just wave files. Let's see, here I've got an MP3 file that I also want to support. So I've kind of abstracted out the things that are common to all audio files and then put the specific stuff in the subclasses. So I can work with this, and then I'm also wanting to, let's go ahead and amplify these things because maybe they're a little too small. So let's pull in some amplify code also. So now I've split my class into a class hierarchy, and I'm going to now call this amplify function. Again, notice it's kind of popping up and helping me out, so I can say amplify. If I open my parenthesis, it helps to say, okay, these are the two arguments you need to pass, and these are the types of those arguments. So that's great. I'll just pass out, and then for gain, because of the great movie, let's just call that 11. And now we've got kind of a problem. So I've tried to pass in an audio file, which out is a wave file. That's a kind of audio file. That should work. But when I try to sign back out, I've lost the fact that it was a wave file, and it's gone all the way back down to the base class, to the audio file. And we can see why that is. We actually look at the type of amplify. We see audio file going in and an audio file going out. And that's not enough information to know what the original type was. So this is where we can actually start to use some of the other machinery in the type system. So we saw type inference. We saw being able to use some of the any types and being able to turn those on. But here, we can actually use what's called a generic. And those of you who've done some C# or Java may be familiar with generics. So let's do one of those. So to say a generic, this is saying that amplify is a generic function. It takes in something that's a t, which is anything. And then we can put that t in both places. So it comes in as a t and goes out as a t. You can think of that as, if you will, kind of pattern matching. Whatever comes in, it's going to pattern match it and then carry that out the other side. Notice that gets rid of our error. But we still have an error up at the top where these properties, like data length and data, we don't know that those are on this type variable t. And the reason that is because we don't know anything about t. T can be any type that it wants to be. So we can actually describe this to the type checker and say, all right, yes, it can be any t so long as that t is of the same shape as audio file. So as long as it kind of matches those set of properties, that will successfully type check. Now we can type check both the inside and any call of this. And now if we run this guy, there we go. So now we are nice and amplified. Something to kind of point out here. So we put in that type information into this into this file. So let's see, where did amplify go? So here's amplify right at the top here, which you may or may not be able to see. There you go. So at the very top, you can see amplify. I'm looking at the JavaScript that's come out. And notice that there are no types anywhere. All the type information that we've kind of put to help the compiler help us when we're kind of in design time or development time, all of that has evaporated away. There's no overhead in that runtime code. So that's kind of a key principle with TypeScript, is that all the type system is only there for development. It's not there for runtime. So there's a couple other tricks that we can do with the type system. Earlier I mentioned that the type system is more configurable. So we can start turning on some of the knobs. There's a lot of type inference going on, but there are places where the type inference isn't helping us out. It isn't able to resolve all the types in our file. So I'm going to set a setting here. And just as an aside, VS Code is kind of helpful when we're starting to write our tsconfig.json file. It's saying, how to help us write it. So I'm looking for something called no implicit any. And what that's going to mean is if any time the type checker has tried to go through my file top to bottom and tried to calculate all the types, if it ever fails to squiggle that and to make me kind of go and annotate that myself. And again, because I've set something in tsconfig, I have to restart code. That only takes a second. So as we start looking through this file now we have a bunch of new errors. So any place that the type checker hasn't been able to infer these types, it will squiggle. So this is kind of a way that you can have high confidence if you go into TypeScript that all the code is typed from top to bottom. Again, this is totally optional. This is totally up to you as a developer. The early days that you're working on your project, you may want the type checker to kind of get out of your way. After you've built up your application to get larger and larger, that's probably when you want to start turning on features like this, that you can lock these things in place and have a fully documented, fully typed application. I'll go ahead and turn this off because for now, that's kind of a little too much. OK. So we've seen moving into classes. And we've seen a little bit of what we can do with class hierarchies, with generic programming, and being able to have generic functions that work over a wider range of types. The next thing I want to do is I want to move our application to using ES6 modules. And there's a couple ways we can do this. I'm going to do this the simplest way first, and then I'll show the Angular 2 way after that. So the first step in moving to ES6 style modules is we're going to take a function, take a file, and we're going to start exporting features out of that file. And so the whole file begins to get treated as a module. So here I'm going to start exporting the first export that I want for this module. Notice we get an error if I hover that error. Excuse me. It says, we can't compile modules unless you turn modules on. OK, thanks, compiler. I'll do that. So we have another feature here that we want to turn on, which is the module system. And we have two kinds of modules we can pick, AMD and CommonJS. And soon that will be 4 different kinds. But one of the nice things here is that we can just use the ES6 module syntax and then select which of these module outputs we want. So here I'm just going to use AMD. So we can use require to load these modules. Again, let's do our reboot jig. And we are back. So now notice that error is gone. Now the compiler knows what kind of module format to use. So let's keep exporting. And I'm going to export enough of this file that will form kind of our API, but I'm not going to export anything that we don't need. So here I've got some, let's export amplify, but let's not export these two because they're not part of our public API. All right, so I'm done with audio file. It doesn't have any requirements itself. It just is like kind of kind of a leaf node, if you will. All right, now let's do display. Notice I'm getting an error here for WAV file. So it's not sure where this is coming from. Now that we started moving into modules, we started moving things out of the global namespace into these separate modules. And the type checker is kind of warning us that we're doing that. So we have to import that WAV file now. So let's start importing from audio file. And then I can kind of auto-complete this and see that there's some things it's trying to assume. It's trying to guess a few places, but where it's got symbols, it knows we've actually done a real import. So let's import WAV file from there. So it's the type checker kind of helping us with our imports too. It's able to both kind of go into imports and then look at the whole project and figure out where your modules are to help with this IntelliSense. All right, and then finally, we need to do the same thing in this file. So we've got a couple imports here we need to do. So let's do those from audio file. If I start typing WAV file, it helps me out. If I do from display audio, oh, I don't actually want WAV file here. I want load file. Great. If I say display audio and I try to autocomplete, it says, sorry, it's not there. I'm sure some of you wily people in the crowd have already figured out why. If we go back to display, notice we haven't exported it. We forgot to export it. So the type checker has actually caught us from doing a bug because that export, we've never actually exported that. So that's actually kind of helpful. And now that we've exported it, we can do the import here. So we're almost done. We've worked through all the imports and exports. We need to kind of simplify how we load our files. So we're not actually waiting for document load anymore. The module loader is taking care of a lot of that for us. And we're not, because we're using a module loader, we're not actually going to load our JavaScript by hand. We're going to pull it in through require. OK, so that was a handful of steps. But the compiler was there kind of helping us move through each of those transitions. Now when we compile this, we should have something that's working with require and is getting loaded by the require loader. All right. And again, run the server. And if we see over here in the debug, we see the require call. So the compiler is actually handled writing out the require flavor of module for us. It's pretty helpful. OK, so we've gone through classes. We've gone through generics. We've gone through modules. The last thing is let's actually start to use this as an Angular application. So the first thing that we're going to do then is we're going to start moving through, which file here? So we're going to move app.ts, and we're going to start with our class that is going to be representing the component that we want to make. So instead of this, let's have a class that will be our component. And this will be, first off, instead of doing the canvas and having the select all kind of pre-baked, we'll have this be that select box, and then that will kind of drive the canvas for us. So we'll call this, kind of our select component, let's say. And select component will have an update selection. And so this is the one that will drive the different features for the select component. And we also have the component decorators that we want. So let's take a quick look at these. But before we do, we have to actually import Angular and Angular 2. So let's go to the command line. And we're going to use a command called TSD. TSD you can get through npm. And TSD goes and searches a repository of type information called definitely typed. These DTS files, like I showed libdts earlier, this will be where we can find the Angular 2 DTS file and its corresponding requirements. So I'm going to install and grep TSD, because these are a little bit more complicated. So here's our first one. We're going to install the Angular 2 action. And this will be the Angular 2 DTS file. And you can see it going and querying and finding this file. And my network is down. Interesting. You might have to do you ever watch those cooking shows where they talk through the ingredients and then they pull the cake out of the oven? Okay, so I'm gonna pull one of those, so bear with me. Actually, let's just jump to this one directly. So that's all right. And then I'll just kind of talk through the steps that we went to get here. Okay, so this is kind of the direction we were going. But let's quickly look at what got pulled down. So I ran that command a few times. There's an Angular 2 DTS file, and that Angular 2 DTS file has the full Angular 2 set of type information. And if you're ever curious what the public API of Angular 2 is, this is a great place to kind of start and read through. There's a ton of stuff, a ton of features there. I'm pulling in a couple of the, just like we were doing in the module imports before, I'm pulling in a couple there. Component view in G4 Bootstrap. If you've seen the to-do in VC app, which I'm sure most of you have, you've probably seen this a dozen times. We create a component called file list. So let's look at the HTML here. We still have the canvas, but now we have the file list component. And we've done a switch, so we're no longer using require. We've got the standard few imports for doing an Angular 2 app. And that will be enough to import our module. The next thing, so we've done our selector. The view, of course, will be actually printing out the template for select. We have our start in G4 over the items. Notice we can do all the type checking in the class. So I've said items are a string array. I can set up the string array if I ever assigned anything that wasn't. String array can kind of warn me. And the rest of it is kind of straightforward, very similar to what we saw yesterday. We load it and then bootstrap it. But without internet connection, this is going to be kind of interesting. So let's see. So if I reload this guy, cross our fingers, aha, did it again. It's thinking. There we go. So now we've moved through all the changes to go into TypeScript. And then from TypeScript, we've moved into an Angular 2 application. And it hasn't been all that much work. we've basically just switched from using kind of a setup function to using a class with a few decorators on that class. The rest of the properties and whatnot on our class, we can, of course, use in the template. But one unfortunate thing here that you may notice is that we don't get type checking inside of the template itself. I think this is somewhere where we can actually kind of grow, as we've been growing this tooling, more and more patterns, supporting more and more patterns. Being able to support inside of the template, I think, would be a great next step. Let me show one final step in the application. So I've kind of taken you through the different stages, and you can play with this. I've got a GitHub repository that you can play with it. I'll show you the link here in a second. This is one final step through this application. And let me run this one real quick. Can you tell I use a lot of Windows stuff? Just saying. Wonder why. All right, empty cache, reload. And here, we got the same application. I've done a couple of things. When I was doing this demo, I was all proud of my canvas. And I was talking to the Ingo guys. I was like, OK, in working with my demo, I've got this canvas. And Brad's like, what? Like, why would you can't, that doesn't work. You need, go to SVG. And that's something where you can actually data bind to. It's like, OK, fine. I'll come to modern day and use SVG. So this is all the SVG version of our WAV file. And I've got some buttons. And if you look to see how that works, again, very similarly, here's our SVG. That's binding to the data of the points. And the points are getting rendered. So we're not doing all the rendering in place in our class. We're just saying what the points are. And all of that logic is getting pulled out and put into our template. Again, to select, and I threw in a couple of buttons there, and all of that is just binding to this class. So we've been able to do a nice separation of concern. So not only are we more modular, we have our concern separated. So the code is nice and clean. And then let's go back to the slides. And this is the link. If you want to play with the demo, I've split the demo into various stages, so the kind of stages that I walk through. And you can play with any stage and kind of jump in where you want to. It's at the link here at the bottom. So there is a kind of a vast wilderness ahead of us. That's kind of what I think of it. We're just starting to see how TypeScript can work with libraries like Angular, and the kinds of APIs that Angular can build on top of the features that TypeScript can provide. And that really creates kind of a whole space to explore of things that we can try by growing the TypeScript language, by incorporating our features into future versions of JavaScript, so like decorators and the work that we're doing at TC39. And I definitely encourage you to kind of come on, work in the community, give us your feedback, and try things out. Thank you. I think we have